Hey everyone, we're going to look at number 11 in section 4.4. We're going to find the critical points C for the function f and apply the second derivative test, which I abbreviate SDT, if possible, to determine whether each of these points correspond to a local maximum, so they're calling that C sub max, or a local minimum, C sub min. And here's our function. And notice they also give a interval. Okay, because we're dealing with trig functions and because of the periodic nature of the trig functions, you'll often have a restriction here because there may be an infinitely many number of local max or mins on the function's domain. So we're just going to restrict ourselves on the interval from 0 to 2 pi. So we want to, first of all, of course, find critical points. How do we find critical points? We need to find the derivative and find out when the derivative is equal to 0. Notice the function here is never undefined because the value of sine of x is always between -1 and 1. So this denominator is always greater than or equal to 3, actually between 3 and 5 inclusive. Okay, so I'm going to just use the I'm just going to use the quotient rule. You could rewrite and use chain rule if you want, but I'm going to do the derivative of the top. Derivative of 6 is 0 times the bottom is still 0, right? So 0 times sine x plus 4 is 0. Minus the top, which is 6, times the derivative of the bottom. What's the derivative of sine x plus 4? Cosine of x. Right, derivative of 4 is 0. And then over the bottom, all squared. So this is just -6 cosine x over sine of x plus 4 quantity squared. Again, the denominator is never 0 here, as we said. But when is the derivative going to be equal to 0? When the numerator is 0, right? So when -6 cosine of x is 0. And that's going to be true when cosine of x is 0, which occurs when x is pi over 2 and 3 pi over 2. So you should know how to find that using the unit circle. Again, the x coordinate of the point is 0 at pi over 2 and also at 3 pi over 2. And again, we're looking on the interval from 0 to 2 pi. So those are the only two values we want. If we open the domain up to all real numbers, there'd be infinitely many, right? We can just keep adding pi over 2 to multiples of pi over 2 to pi over 2 to get more solutions. So again, we're only going on the interval from 0 to 2 pi. So these are the only critical points. Okay. So the question is which one of these is C max, or are they both C max, or is one or both C min, and so on. We need to find that out. So you have to use the second derivative test. So real important, you're not using the first derivative test. So we're not doing a sign check on the first derivative. You could do that to determine whether we have a local max or min, but the instructions are to use the second derivative test. It's going to be real important that you follow the directions on the test to use the appropriate test. Okay. What is the second derivative? Well, I'm going to use the quotient rule on my derivative here to find my second derivative. So the derivative of the derivative. What's the derivative of -6 cosine x? Well, the derivative of cosine x is negative sine x. So I get -6 times negative sine x, positive 6 sine of x. Over the bottom function, or times the bottom function rather. So derivative of the top times the bottom minus the top, which is -6 cosine of x, times the derivative of the bottom. Well, the bottom involves the chain rule, right? I have inner function sine x plus 4, all to the second power. So the outer function is u squared. The derivative of u squared is 2 times u, where u is sine x plus 4, times the derivative of the inner function. The derivative of the inner function, derivative of sine of x, is cosine of x. Derivative of 4 is 0. Cleaning this up a little bit, notice I have a factor of sine x plus 4 in both my terms. My first term, I have this factor, sine of x plus 4, and here I have it sine x. So I could factor a sine of x plus 4 out, and I can divide it with one of these. Basically, what happens is I can divide through and get rid of one of that extra sine x plus 4 factor. So what I'll have is 6 sine of x. There'll be 1 sine of x plus 4 left here. Minus a negative is positive. 6 times the 2 is the 12. cosine x times cosine x is cosine squared x, all over sine x plus 4 cubed. Okay, so basically I factored out one sine x plus 4 factor from both of the two terms up top, and then divided it with divide top and bottom by sine of x plus 4. Okay, and you can distribute this through, can't really combine. You get a 6, you can't simplify very much. 6 sine squared x plus 12 cosine squared x. If this was a 6 cosine squared x, you could use the Pythagorean identity to simplify this down. But the main point is you don't really need to simplify. We just need to evaluate. So second derivative test has you evaluate the critical points. Just plug in, right? Pi over 2 into the second derivative. What's that? Well, sine of pi over 2 is equal to 1, right? Where cosine of pi over 2 is 0, sine of pi over 2 is 1. So I get 6 times 1 is 6. I get 1 plus 4 is 5. Cosine, again, of pi over 2 is 0. This is 0. This whole thing is 0. Again, sine of pi over 2 is 1 plus 4 is 5 cubed. I can cancel one of the 5, so I get 6 divided by 5 squared, or 6/25. Important thing is it's positive, right? If it's positive, the second derivative test tells us that f of pi over 2 is a local minimum. Okay, why is that the case? Well, again, if the second derivative is positive on an interval, function is concave up, which looks like this. But we also know at pi over 2, we have the derivative equal to 0. So where are we on the curve if the derivative is equal to 0? We're right here at the bottom, right, where we have a horizontal tangent line. And what do we have? A local minimum. On the other hand, the second derivative evaluated at 3 pi over 2, well, sine of 3 pi over 2 is -1. So I get -6. -1 plus 4 is 3. Cosine of 3 pi over 2 is 0. So this whole thing again is 0. Sine of 3 pi over 2 is -1 plus 4, 3 cubed. And I can divide one of these 3's and I get -6 over 3 squared, -6/9, or -2/3. Important thing is, again, it's negative, it's less than 0. That implies that f of 3 pi over 2 is a local maximum. And why is that? Again, second derivative test is telling us that since the second derivative is negative on this interval, the function is concave downward, right? And again, though we know at 3 pi over 2, the derivative is 0. Where are we at on this curve? If the derivative is 0, we're right here at the top where we have that horizontal tangent line. So we have a local max. So you need to know how to apply the second derivative test. So in terms of achieve, they've got a space that says C max, right? Remember, C max is the critical point that gives the maximum. Well, obviously we just said that's going to be the 3 pi over 2. C min is where we have the local minimum, and that's going to be at pi over 2. Okay. So that's how the second derivative test works. It's very nice. No sign check needed on the second derivative test. First derivative test, you need a sign check. Second derivative test, no sign check needed. Okay, hope this is helpful.